So I have a dream. I may be young, I may be naive, but I believe in a world where we can have stable, reliable production environments. This is what we hope our systems look like. Everything works. But this is what our systems actually look like. Fires everywhere. We know production is extremely complex and hard to untangle. We know 100% uptime, it just doesn't exist. More importantly, sometimes we know things are broken, but we don't know how to fix it, especially in prod. There's a fear, there's a culture, that if we go into prod, we might blow everything up. Okay, I'm gonna have to move over here, sorry. So we're gonna take a look at the principles of chaotic engineering to help us out here. What is chaotic engineering? It is when we try to address chaos and build systems that can withstand realistic, everyday conditions. Chaotic engineering has become a major buzzword. We hear things like, I break prod, I break things on purpose, I test in prod. I'm here to tell you that chaotic engineering is not cowboy engineering. We're not trying to sell failure as a service. We need to learn our vulnerabilities, and we can't wait for a fire to set those alerts for us. Looking at the principles of chaotic engineering, we can help learn to address some of our issues. First, in step one, we need to know what our steady state is. What is our normal? Our goal is to learn what is and what is not working in our systems so that we can put the engineering effort to harden those systems each and every time. But if there's fires in your environment every single time, where do you start? This is what I consider pre-chaotic engineering. You'll have to get your system to a steady state. Some ways to do this is establish meaningful observability, set SLOs, and come together as a team to fix your systems. Step two, so you're ready for steady state. You'll have to hypothesize your steady state. If you were to inject failures, what would happen? How would your system behave? Even if you don't practice chaotic engineering, you can actually do this with your team because it really helps you map out all the possibilities of what can go wrong within your environment. Step three, inject those failures into your system. You want to start in lower environments and work your way up towards prod. There's an O'Reilly book online that can help you navigate these experiments. Step four, disprove your hypothesis. Go through your evidence and see if your steady state was impacted by the experiment. If you found something, this would be the time to go ahead and fix it. So then chaotic engineering doesn't sound so crazy. But why is my talk called continuous resilience engineering? Continuous resilience engineering focuses more on building reliant systems from the very beginning. It also really focuses on postmortems. It says that you have to take proactive failure testing, so chaotic engineering, and group it with post-incident reviews, and they go hand in hand. And also, resilience engineering puts a lot more emphasis on containment and blast radius. Containment and blast radius should be your utmost importance. In order to control your experiments, especially if you want to move to prod, you must do the following. Communicate, communicate, communicate. Get buy-in and work with your team. Collaborate. You need to run it during office hours where SMEs are available, avoid important dates, have a rollback plan, and start small. Get familiar with tools that also support chaotic engineering. But no matter what, failures are inevitable. We need to take calculated risks and plan accordingly so that we end up with better systems each and every time. We want to have confidence in our systems so that knowing they can withstand fires. Nobody wants a hot mess for a prod. Over time, the more we test, the more we poke, the more we fix our environments, and the more our systems become hardened. What doesn't kill you makes you stronger, except for bears. Bears will kill you. So start small, plan accordingly. Containment and blast radius should be your utmost importance. Your focus from the beginning is to build resilient systems, understand and untangle your prod, get to a steady state, and engineer your systems. And who am I? I'm Suzan Mahboob. I'm the leads program engineer at TD Bank for their cloud infrastructure team. I'm also a committee member for DevOps Days Toronto, so I personally thank you for attending this year, and I thank you for listening to my talk. Bye.